Um, Hello everyone. So kule video sizodiscussa topic yama-functions and graphs for grade 10, right? So as an introduction, we'll sort of go through the notes and maybe do a few examples as we go, right? So into engizoyenza, I'll just read through and try to explain lokhu ekuchazwa ama-notes, and then if possible senze nama examples, right? So I believe within the best way to approach this topic is to attempt a lot of past exam papers to be familiar with the questions and ukwazi ukuthi wa approach njani, ne? Okay, so let us go ahead and read. So here we begin by trying to answer the question of what a function is, right? So when we're talking about a function, you can think of a function as a machine or a system where you have inputs and outputs, right? In order for you to get an input, in order for you to get an output, you have to give an input into that function, right? So an example of a function is the function or the graph of the line y equals to x, right? So if we have y equals to x, it means for every input we will get the same output, right? So our x values will represent the input and our y values will represent the output, right? So if your equation is like this, y equals to x, it means for every input you will get the same output you'll get the same. Okay, so if you have x, y equals to x, and your x is 1, it means your y also has to be 1, because for every input that will be your output, right? But then if you have the function or equation y equals to x plus 1, it means you will increase your input by 1 in order to get your output, right? So the input is an independent variable and the output is the dependent variable, because it depends on the value of the input, right? So x is their independent variable. X is your independent variable, y is your dependent variable, right? Y is your dependent variable because in order for you to know y, you have to know x first, meaning y depends on the value of x. Just like in this equation, y equals to x plus 1, you cannot have your y without having the value of x. But if you say x is equals to 2 and then you substitute 2 into that equation, you will have the value of your y depending on what your value of x is. So there you will have 2 plus 1 to get 3. So in this equation, when x is 2, you'll get that y is 3, right? So y is 3 means for an input of 2 and an increment of 1 on that input, we get an output of 3. So now when you think of a function, a visualization of a function, you can think of it as a set of ordered pairs, right? Ordered pairs of your independent and your dependent variables, right? So when you have your Cartesian plane, your x and y axis, on the x-axis there we have our inputs or our independent variable, and then on our y-axis we have our output or our dependent variable, right? So now a function can also be represented as a set of ordered pairs of independent and dependent variables, right? So if we have the function y equals to x plus 1 and pick a few points maybe for x, when x is minus 1, we know ukuthi substituting minus 1 there, we will get 0. And then when, okay, let us start at minus 3. When x is minus 3, we know ukuthi y will be minus 2. And then when x is minus 2, we know ukuthi y will be minus 1. When x is minus 1, we know ukuthi y will be 0. When x is 1, we know ukuthi y will be 2. And then when x is 2, okay, so when x is 0, we know ukuthi y will be 1. And then when x is 1, we know y will be 2. And then when x is 2, we know ukuthi y will be 3, and so on, right? So now we have pairs of independent and dependent variables. When you plot this on your Cartesian plane, you will have minus 3. Let's say this is minus 3, this is minus 2, that is minus 1. This is 1, 2, 3, that's 1, 2, 3, minus 1, minus 2, minus 3, right? And then when you plot these points, you'll have minus 3 and minus 2 will be there, and then you'll have minus 2 and minus 1 will be there, and then we'll have minus 1 and 0, that will be there, and we'll have 0 and 1, which will be there, and then we'll have 1 and 2, sorry, which will be somewhere there, and then we'll have 2 and 3, which will be somewhere there, right? And then when you connect a straight line, when you connect these dots with a straight line, you get the representation of your, you get a visual representation of your function, right? Yeah, so let us go through the notes again. So a function is like a machine. It has an input and an output. Is in the isichaza ukuthi for us to get an output we need an input, right? For every input we have an output, then we have a function, right? There's a relationship between the input and the output values, right? Just like in the case of y equals to x plus 1, right? This is a relationship between the input and the output value. We know what our output value is the dependent variable. It depends on the input value, right? So this equation describes the relationship between the output y and the input x, right? It says that for every input x, increase that input by 1 to get your output variable, the value of your output y, right? So that is a relationship. Okay, a function is like a machine. It has an input and an output. There is a relationship between inputs and outputs. The output depends on the input. Njengoba ngisho ukuthi y depends on x because y is our output and x is our input, right? So we say that the output is the dependent variable and the input is the independent variable, right? Because if y is your dependent variable and x is your independent variable, it means in order for you to get y, you have to know the value of your independent variable x, right? So another way of looking at functions is to use function notation. F of x equals to something, right? So instead of writing y equals to x plus 1, you can have f of x equals to x plus 1, right? This sort of like specifies ukuthi the input variable is x and then your function name is f, right? So now this f of x is the value of your output, right? It is the same as y. Y is equals to f of x. Ne? So now f of x is the classic way of writing a function. The rule or a function. So in a function we have an input and then we get an output, right? Our input, because there's a relationship between the input and an output. If we put the value of the input into our function, we will get the value of our output, right? So now you see what an input is an independent variable and output is a dependent variable, right? There's also relationship there's also a relationship between the variables, the independent and the dependent variable, right? A function relates inputs to outputs. Njengoba ngichazile, in order for you to get y, you have to know x, and then depending on the relationship, the value of your output will depend on the value of your input, right? A function is a special type of a relation in which the output value is dependent on the input value. Any input produces only one output, right? So any input produces only one output, right? If a function, in order for this relation here to be a function, for every input value we have to get only one output value. Just like in here, if x is -3, we know what our output value is -2. Nowhere else do we have -2 in here, right? So no other value of x gives us -2 but besides -3. I don't know if that makes sense, but the point is every input can only match to one output. Every single input can only match with one output, right? You cannot have let's say you cannot have where you cannot have an input of -3 and then get an output of -2 and then again have an input of -3 and then you get an output of -1. So this will not represent a function. I don't know if that makes sense, but hopefully it does. So okay, we can go P. Any input produces only one output. An input and its matching output are together called an ordered pair. A function can also be seen as a set of ordered pairs, right? Njengoba ngichazile lana ukuthi this is a set of ordered pairs, so this can be a representation of a function, right? In a form of a table, and then this one is a representation of a function in a form of a graph, right? It is a set of ordered pairs, right? A pair of independent and your dependent variable. Okay. At this point, ngifuna ukuthi worry too much in context, but then just try to understand it looking chogo. But then if you don't fully understand what I'm saying, ungawari, it will make more sense as we do examples or attempt past question papers, right? So this is purely for understanding what does it mean ukusebenza ngama functions, and then ukuthi ukhona interpreter if you have an equation like this. For example, if you have y equals to 2x plus 3, you should know ukuthi y is your independent variable or the value of your function, and it depends on your input variable, which is x. X is the independent variable, right? And then this relation here is a function if for every x value you get only one output value, right? So first it is useful to give a function a name. So the most common name is f, but we can also use other letters, but f is most commonly used in mathematics. So if you have an equation like this, f of x is equals to 2x plus 3, f is the name of your function, x determines this is our input variable, and then this 2x plus 3 is the relationship between our input and output, right? So we read this statement as f of x is equals to 2x plus 3. Okay, so what goes into the function is put inside the brackets, right? So after the name of the function, we put x to determine what it is our input, right? And then this whatever that's inside the bracket will go into our function, right? So f of x shows that the function is called f, and 2x plus 3 tells us that the function takes x, which is our input, and multiplies it by 2 and adds 3. Okay, so the answer is the output. The output value uniquely depends on the input value. An input of 3 gives an output of 9 in this equation here. If you substitute 3 there, you will have 2 times 3, which is 6, plus 3, which is 9, right? So 3 is your input value and 9 is your output value. And that output value depends on your input value, which is why we call the y variable the dependent variable, right? The input and output values can be plotted as coordinates on a graph in the form of input, output, and yeah, njengoba ngichazile lana ukuthi another way of representing a function is to have points plotted on the Cartesian plane, and then this will be ordered pairs of inputs and outputs, or independent and dependent variables. Okay. So when we plot in the Cartesian plane, the function forms a straight line of that kind. Okay, so we know with a function okay, a straight line is in the form y equals to ax plus q, or Tina will just use this form y equals to mx plus c. They are the same thing, just some letter different. M is our slope or the gradient, and then C will be our y-intercept, right? We'll go more into detail on how to sketch a straight line and how to determine the equation of a straight line if you are given the graph of that function, right? Okay, so graphs of functions. Alright, but at first it may be helpful to generate a table of values using numbers from the domain, which are the x values. Your x values should include examples of negative and fractions. The graph of the parabola y equals to x squared is this graph here. The graph forms a parabola. The axis of symmetry is the line x equals to 0. And your x values are the domain and your y values are the range. The turning point is where the graph goes from decreasing to increasing, or the turning point is where the graph changes direction. And then the intercepts with the axis, your x-intercept is when you let y be 0, and your y-intercept is when you let x be 0, right? We'll go more into detail with how do we find the equation of a function if you are given a graph, and how to sketch a graph if you are given the equation of a function, right? So now we are just like having an introduction session. Okay, and then we also have the graphs of the hyperbola, which are in the form y equals to a over x, right? The graph forms a hyperbola, and our axis of symmetry is the line y equals to x, or the line y equals to minus x, right? So an axis of symmetry is sort of like a mirror line. If we talk about the axis of symmetry, we are talking about okay, let us say we have maybe an image of a person here, and then that person is standing in front of the mirror, and then what they see on the mirror is like an image of their self. So this line here in the context of function is the axis of symmetry, right? We imagine this to be a mirror, right? So this line is the axis of symmetry, right? So in the context of function, a mirror line, or but then in the context of function, if you have a line and it sort of like shows an image of a, if you, okay, let us use an actual example. Okay, we have a, let's say we have a graph of a hyperbola here, of a parabola, sorry, right? Now the axis of symmetry for this graph is the line x equals to 0, which is this vertical line, or the y-axis, right? We're calling this the axis of symmetry because it sort of like cuts the graph into two equal halves, or you'll see this part of the graph is a reflection of this part of the graph. So this is sort of like your mirror line, right? So that mirror line, we call it an axis of symmetry. Now for a hyperbola, that mirror line will look something like this. Will be, okay, a hyperbola is like this. Now your axis of symmetry for a hyperbola, they're saying is the line y equals to x, which is the straight line, right? Now this part of the hyperbola is being reflected across this line y equals to x to give this image here, right? Another axis of symmetry for the, okay, this is y equals to x, is the line of symmetry, or the axis of symmetry. Another axis of symmetry for the hyperbola is the line y equals to minus x, right? Notice this piece is a reflection of that piece across this axis of symmetry, right? Okay, that is the graph of the hyperbola. We also have exponential functions. No? We also have exponential functions, and they are in the form y equals to b to the power x, where b cannot be a negative number and b cannot be 1, right? The graph forms an exponential graph, and the axis of symmetry is the line y equals to x. Okay, I don't think the exponential graph has an axis of symmetry, because it sort of looks like this, and then the line y equals to x is this one. Okay, but then I'll confirm if an exponential function does have an axis of symmetry, but I doubt it does. Okay, so we have the exponential graph. It has the form y equals to b to the power x. Yeah. Okay, so now this is sort of like an introduction. We'll go more into detail ngalama different types of graphs when we are doing questions, right? I feel like the best way to approach is a section or a topic yama functions nama graph is through exam papers or doing past question papers, right? I feel like kuzoba easier for me to explain and for you to understand if we are working with actual examples. So what I'm doing here is sort of like covering the theory of functions and graphs and trying to explain what is actually happening. But then if our understanding looking shogo ungawari, think it will make more sense once we start doing examples. Right now you'll be familiar with the way you're supposed to answer the questions, and yeah, I think it will be more clear when you start doing questions. So for now, if you don't understand what I'm saying, ungapaniki, just relax. It should make more sense when we are doing questions. Ne? So the graph y equals to ax squared plus q is another form of a hyperbola where a determines the shape, q determines the y-intercept, right? If the shape is positive, if the value of a is greater than 0, or if a is positive, and then you'll have this upward shape, and then if the value of a is negative, you'll have this downward shape, right? And then the range for the value of a, for positive a value, the range will be y greater than q, and then for when a is less than 0 or negative, the range will be y is less than q, and then the domain is x, element of real numbers, right? The effects of q on the graph, the effects of a on the graph is they affect the shape, and then they also affect the wideness of the graph, right? And then the effects of q on the graph is they affect the y-intercept, because q is sort of like a vertical shift of the graph, right? And then there's also another form of the hyperbola, which is y equals to a over x plus q. That part should be plus q. And then the domain and range of the hyperbola is, the domain is all x values except 0, because you can't divide by 0. And then the range is all y values except q, because q will be our asymptote and the graph cannot cross the asymptote, right? Okay, I think I should stop here for now, and then sort of have your response ngale video, unginikele feedback ngale video, sort of like ngizama ukubona ukuthi isection le ngichaze njani, because ngendlela engichaze ngayo I don't think it will make sense to you as yet, unless if maybe you are already familiar with functions. But yeah, use this as an introduction. If you don't understand, don't stress too much. We'll cover questions, and then from there I think uzokhona understand. So for now ngizojama la, and then ngizama ukuthi siqhubekise, right? So I believe we sort of have like an introduction and an idea of what functions are, and yeah, okay.